Alright, so I think this is recording. We're taking a look at skill packet 5, exponential and logarithmic functions, and here in 5F we're looking at equations, log equations, and using properties of logarithms in order to solve these. Um, on the left hand side we have the sum of two logarithms with the same base. We can write that as a single logarithm by the product rule, that this sum of logs is equal to the product of 2x times x minus 3, and we can write that as a single logarithm. And the same thing over here. Excuse me. We've got 5 times the quantity x minus 1. So now we know that these log equations, log functions, just like the exponential functions, are one-to-one functions. They pass the horizontal line test. So if these numbers are the same, then these arguments have to be the same. And now recognize too that the bases have to be the same. So this 2x times x minus 3 is equal to 5 times x minus 1. This is a quadratic equation. We need to rewrite it in standard form to attempt to factor it. If we can't factor it, complete the square or use quadratic formula. We've got 2x squared minus 6x is equal to 5x minus 5. Like I say, to get it in standard form, let's subtract 5x from each side. We've got 2x squared minus 11x. Let's add 5 to each side. And now we've got 0. When you're factoring and your leading coefficient is different than 1, and especially, we're lucky that 2 is prime, it'll make it easier. But if this value is a large composite number, that's when that X method that the Algebra 1 team here at Northview uses to teach Algebra 1 students to factor really is a nice tool. Now here it's not that difficult because both 2 and 5 are prime, that we can do it by trial and error. We know that 2x times x gets me 2x squared. With this guy being positive and the middle term being negative, I know that both of these are negative, and to get a negative 11, well, here the 2 times negative 5 is negative 10 minus 1 more, and I get the negative 11. So now if I have a product that equals 0 by the zero product theorem, either 2x minus 1 is equal to 0 or x minus 5 is equal to 0. But with these two-step equations, most students don't have to write that. They just look at this and they know that half of 2 is 1 and 1 minus 1 is 0. So x is 1/2 or x is 5 are possible solutions. However, when we plug in 1/2, we've got 1/2 minus 3 right here, and even 1/2 minus 1, we can't take the log of a negative number. Now when we plug in 5 minus 3, hey, that's positive, and 5 minus 1 is positive. So we're good to go on this one. Alright, so there's my solution for 9. Let's go ahead and do 10. Now, even though it looks like to some students that we have log equal to a log, this 3 times the log of x, really you have log of x plus another log of x plus another log of x is equal to a log of 2x plus a log of... You don't have log equal log, not yet anyway. So what we need to do is have log equal log if we want to apply that one-to-one function idea. So by the power rule, this coefficient of 3 on the left-hand side, I can write this as a single logarithm. It's the log of x cubed. And on the right-hand side, I have the log. Now the parentheses around this are important because this base now has an exponent of 2. It's 2x times 2x, not just the x squared. So now I have a log equal to a log. The base is not written, but it's a common log. Base 10 is implied. We're supposed to recognize that base 10 there is implied. So since these are the same bases and these are the same numbers, these arguments have to be the same. So if you have x cubed is equal to 2x squared. Now this problem brings up a unique conversation about solving equations. We've seen, throughout many of these skill packets and a lot of these equations that if you multiply both sides by a variable, that you have to check for extraneous solutions. And that's pretty easy to do. You just have to remember to check your answers. sometimes you'll see students in this situation divide both sides by a variable. When you divide by a variable, there's a possibility that you might lose a solution. Well, when you get your final answer, like I say, it's easy to check to throw something out, but how do you look at it by inspection and realize, oh, there's supposed to be another answer here that I don't have? It's practically impossible to see it. So rather than divide both sides by a variable, you want to subtract. So we need to get this equation equal to 0. On the left-hand side, we've got x cubed. On the right-hand side, we have 4x squared. I'm going to subtract 4x squared from each side. So now, when I look at these two terms, they have an x squared in common, and then I have an x minus 4. So this original equation up here, that if you had just divided by x squareds and stuff, you're going to lose this 0. Now, you might get lucky in this problem because we can't take the log of 0, so this is extraneous anyway. But that's not, just if we had, let's do this over here to be clear. If over here, if I had a student that said, hey, I'm going to divide this by x squared and get the x is equal to 4, there's no way for you to look at that and really recognize that, well, I guess if you're good with arithmetic, 0 was a solution to the original equation. But when you divide it by x squared, see, you're not allowed to do that if x is allowed to be 0, so there's no way that simplifies to just 4 if x is 0. So when you avoid dividing both sides of an equation by a variable, and if you have to multiply it, then check your answers to make sure it's extraneous. So back to over here, our answer to this is x equals 4. We got lucky that this guy was extraneous, that had we made this mistake of dividing by a variable, we would have got lucky and had the correct answer. But our technique, how we got that answer, is wrong. All right, so I hope that helps, and talk to you later.